Lecture 19 covers Section 6.4. At the end of today's lecture, you should be able to analyze a variety of operational amplifiers. This includes inverting, non-inverting, differencing, and bridge operational amplifiers. And we will do such using node voltage analysis. If we recall from our previous lecture, we introduced our inverting operational amplifier. That is, our output was proportional to the negative of our input voltage. We will define K as our gain, i.e. our output voltage, per our input voltage. If you recall, our output voltage was equal to the negative of Rf per R1 times our input voltage. For we applied KCL at the node associated with V1, and we looked at I in entering and I1 plus I out exiting, where I1 was equal to 0 and V1 was also identically equal to 0. Thus, we were able to express our output voltage in terms of our input voltage in terms of minus Rf per R1. Now, defining K as a ratio of our output to input voltages, we have the following. K would be equal to minus Rf per R1. And we notice it's an element of our number line from negative infinity to 0. That is, K can be equal to negative infinity as R1 tends to 0 or Rf tends to infinity, or K can tend to 0 as Rf tends to 0. Now, if we define the absolute value of K, we can have two unique situations. That is, if the absolute value of K is greater than unity, we have amplification, which means our output signal is greater than our input signal. If the absolute value of K is less than unity, we have attenuation, which means our output signal is less than our input signal.